Right, so my name is Brojak. I'm in RS Components. A little bit about my background. I've been doing electronics design, embedded design for about 5 years before joining RS. I've been doing some cool stuff, which were designing some control systems for heavy machinery like firefighting trucks, road sweepers, so a lot of cool stuff that I'm doing with electronics. When I joined RS Components, my old design activity has stopped and I get to do even more cool stuff, which is I'm looking after our electronics applications. So this is a little bit cryptic. Electronics applications at RS are pretty much pieces of software that help engineers worldwide to design faster, to save their time, and to reduce that time from design to manufacturing, in a nutshell. As Pete mentioned, this is going to be about Raspberry Pi and about what we can do with Raspberry Pi. So when it all first came out in the beginning, that's Pete in the picture there, by the way, we've seen this great opportunity that Raspberry Pi is providing, and this is why we became one of the main distributors of Raspberry Pi. This is very much within the spirit that we are working at RS, educating the engineers of tomorrow. We are always supporting these sort of activities. We are heavily involved with universities as well. When I first saw the Raspberry Pi, I'm more of a hardware guy than a software guy, and I think this is what I've experienced with the embedded design is that by writing a few lines of code, I was able to actually make things happen and make something moving or read some analog to digital reading or stuff like that. And this is my first thought was, okay, how do we connect something for these kids who are using Raspberry Pi for learning electronics? How do we stop them from just doing computer science on the Raspberry Pi and go more into hardware domain and actually interact with this Raspberry Pi? So I think that actually connecting some electronics hardware to a Raspberry Pi, it's a lot more fun for these kids to get into what electronics is all about. So having a Raspberry Pi, by the way, does anyone not know Raspberry Pi here in the room? Okay, that's very good news. So on Raspberry Pi we've got that little interface header. It's a 26-way connector that's got some I/O interfaces to external hardware. And there are some problems with this connector. So the problems are that the GPIOs on there are not protected. So pretty much connecting stuff to it by an inexperienced user or even experienced user who is not careful, we put our Raspberry Pi at risk. And now maybe it's easy to get the Raspberry Pi, but a year ago it was quite difficult to get it, so people were very precious of this Raspberry Pi. And obviously this is something that needs to be taken care of by this external hardware that we are connecting. And also there is really not much power in that external connector. I think there's something like 50 milliamps a load, so we can't really power anything serious with whatever is there on board. Therefore we require an external power supply for whatever we connect to Raspberry Pi. So when looking at what sort of hardware we can connect to Raspberry Pi, first of all we need to address these problems of the GPIO connector. And what we're thinking, we would like to achieve the maximum flexibility so that really anything can be connected to Raspberry Pi without clearly defining the hardware that goes with Raspberry Pi. We want it to be low cost as it is targeted as education market, so we want to make sure that this doesn't cost a whole bunch because we got to go with the spirit of Raspberry Pi. It's a cheap thing, and we have to make sure that this is not going to be a big expense to educational institutions. And yet, of course, we want to make it open source. We don't want to be precious of our design files. In fact, we want the community to then get these designs and improve them and make them better. So the product that we came up with is called PiGo, and now you can take it out. It is also on a picture, and we're going to have it here so everyone can have a look later and from the close distance. Pretty much what it is, we went for a modular approach.
Shall I pass it around?
Yeah, pass it around by all means. Yeah. So it is a modular approach. We've got the baseboard on which we can plug in up to 4 modules at a time, and they are all interchangeable. So this is the flexibility that we had in mind. And when the board arrives to your hands, probably in some time, you will be able to see that. And you can play with it. You can actually unplug these modules. And there is another board that I built just as an example that also plugs in there. That's probably good if they go together. So a little bit about the baseboard. I have to say, you can interrupt me at any time if you have any short questions and leave the bit longer questions for the end. So the baseboard, this is something that I sort of planned out and I was involved in designing that. Mainly the first modules that we get, that we see on that board is something that is designed by an external company. So I probably know a little bit less about these modules. So then what we have got on the baseboard, we've got of course the sockets for the 4 modules. And they are not dedicated for any modules, they are all interchangeable. We've got a power supply, 2 amps, we've got a bunch of power supplies for 3.3 volts to power each of the electronics on each of the modules. We've got some extra I/Os, so we've got a couple of 16-bit I/O expanders just to give a lot of bits and a lot of flexibility with this stuff. We've got some LEDs, we've got some push buttons, anything that is really needed to interact with Raspberry Pi in a very easy way.
Does it have any AC/ADC on it?
So
I've just got the question at the right time.
Sorry.
So your next slide.
Your next slide
okay.
answers the question.
So let's look at the modules. The first module, analog to digital, digital to analog, pretty much speaks for itself. The second module, a motor controller, again to make something moving, to get these kids excited about something when they can make it run from the Raspberry Pi from typing some commands on the keyboard. I think this third module is the most interesting one. So what it is, pretty much this is an Arduino clone. It's got the Altmega 328 chip on it, so the most popular version of Arduino. It takes the Arduino shields on top as well. So I think what we have, what is the potential of this module is that we can bring the Arduino community to actually start using Raspberry Pi, and vice versa, get the Raspberry Pi community to actually start reusing whatever is the hardware is already available for Arduino. And that gives the possibility of reusing the software that anyone might have written for Arduino before, or just reusing all this abundance of software for Arduino that is already there, available for download all over the internet. And the final module that we have from this set of starting modules is the prototyping module. This is just a 3D screenshot and it shows a little IC there, but in fact, as you can see on that board, this is an empty module just to allow people to, or the kids at schools or whoever is using this board to solder some components on there and prototype whatever they want to make working with Raspberry Pi, without the need of taking care of the GPIO protection or extra power supplies or any of this stuff. So going straight to the functionality. And for these initial modules, we also have some software available with this IGO board, and this screenshot just shows the graphics user interface that we have running on a Raspberry Pi. And this software has been used for testing, but obviously this acts as the base and the first step for anyone who wants to use these boards. Also, the boards are compatible with a standard prototyping board. So if that space on this prototyping module, because it is quite a small space, if this is not sufficient, then it is possible to get a piece of prototyping board and pretty much plug it in across, for example, 2 modules horizontally or vertically, or even if this is not enough, one big prototyping board can be plugged in across all the 4 modules actually. So this is all on the 0.1 inch grid. Okay, so I'm not sure if I used the right logo. I'm very new to this, all the open hardware concept, and in terms of all this legislation and what can go on the boards and what can't. We very much so want to have all the design files available. This will be all for download from our community website. It is all in DesignSpark PCB format. Is there anyone who doesn't know DesignSpark PCB in the room? Okay.
What do you mean, don't know it?
Who don't know in terms of what it is and how. Right, so it is, I mean, the good thing about it is that this is a free software, so anybody can use it. It doesn't have any restrictions, and it gives this opportunity for actually taking that product and, I don't know, embedding it into someone's product if someone is a professional, or mainly for students, for the school kids to actually get more interested and see the opportunity that they don't need to have any piece of expensive software to actually take a piece of something and start modifying it. And that can be quite an inspiring experience for them, which is not available with paid-for software. Again, why it is also good is that the complexity of the modules is very low, because the modules are only the extra functionality and whatever someone wants to put on there, and whether it's a tilt sensor or stuff like that. They only need to connect the communication line like SPI to that tilt sensor, and that's pretty much it. It works. So they don't. So designing these modules is very simple, and once the design files are already there in place, the connectors are in the right place, and it's just very easy to expand. So just with all these 3 points, it makes it an ideal platform for schools, for universities, just because of that openness. So where we are now with the Pygo boards, we are at revision 1, and the one that you are looking now at, this is pretty much the first prototype. We've got 15 of these prototypes that we want to give to enthusiasts and to these innovators and early adopters, which most of you guys are. And in exchange for some content generation, we want you to review it, to tell us, what can be done better, to make sure that once we go to the production stage of this stuff, that we actually hit the spot and we have got the best products and best suited for our target audience, which are the school kids. And that includes generating some software examples and some, even simple examples of stuff built on the prototyping board, like the LED coming on and stuff like that. So down to all this very simple stuff. The next stage is, of course, the revision 2. We've already, if you see at that board, there are some hand modifications, so we are going to rectify all of that. We are going to take the comments on board from whoever is going to be the test user of the revision 1, and the revision 2 is something that we are going to roll out to a wider audience. So I think from these 15 prototypes that we had, we still have a few available. So if any of you are interested, then please do let us know. What are your ideas? What do you think you can do with it? And then we certainly can look at giving a set of these boards to you so you can play with it. The revision 2 will be a wider audience, so we are going to look into putting this up on Kickstarter and getting something like 100 people to get their hands on it and actually produce some software examples again and come up with the ideas how this can be used in the education environment. And this is very important because when it comes to school teachers and to kids, they can be put off very easily if something is complicated from the beginning. So we need to go down to very simple things that can be done. When kids start learning this, they will see the opportunities, and a lot of them will just don't stop there, and they will go further and further and see where are the limits. Our target sale time, if providing that the revision 2 will be the final revision, is July 2013. So this is when anybody will be able to get these boards, and again, for education market or even for if someone is planning to develop a product that goes with Raspberry Pi, this is just a perfect prototyping platform. It's something that can be used very easily for the product development. And I'm not going to do any sales pitch. These are the RS products, our standard soldering station and multimeter. And why I'm showing them here is because anyone who gets this the set of the Pygo boards, we are going to throw one of these in for free for you guys so that you can use it to play with the Pygo boards. So it's just a freebie for whoever comes up with the good ideas, and will get this a set of the boards. So, questions?
So what is the cost of that?
Okay, I did forget to mention that. So let's go back to the baseboard. So going through the baseboard, The baseboard is aimed at the moment at below 30 pounds. Below 30 pounds. Yep. And then the modules around 10 pounds each. So we are looking at getting, for education purposes, to get the set of the boards, including the Raspberry Pi and the basic education package below 100 pounds, which we think is affordable for as an education package.
As the Raspberry Pi is a Broadcom chip and the 80 mega is an Atmel, well, how do you actually talk to it over the system?
So it just goes through the standard serial communications. There is always
so it's like text code.
That's right. Yeah. It's there is a different voltages, so the translation between 3.3 and 5 volts.
So why did you go with the GPIO pins and not the USB?
Why did we go with the GPIO?
Well, you can connect an Arduino to the USB and then do exactly what you just described.
Yeah, I think that the Arduino module is just one of the modules and one of the possibilities. We never, it's not an intention to, for this system to be solely about Arduino and Raspberry Pi. Arduino is just one of the possibilities.
But if you connected it to USB anyway, you'd have to have a USB to USB UART anyway, so that's another component. And there's a UART on the GPIO, so you know the Arduino doesn't, that mega chip doesn't speak USB natively.
No, only. I was just thinking in terms of simplicity for school kids.
Yeah.
Yeah, you know, they just plug the two together at the moment, they can do that now.
You might as well put the Raspberry Pi at one level. I'm looking at it from a completely different angle. You can just put the Raspberry Pis on that board. You've got the costs now of buying a Raspberry Pi and a development board, which is sort of all that real estate of PCB. The Raspberry Pi electronics would fit in the corner of that board.
Yeah, but then it wouldn't be a Raspberry Pi, would it?
Well,
thinking of costs. Mike, have you engaged with the schools yet on this? Because I'm conscious of the number of schools who've contacted my company saying, can you sponsor us because we can't afford £30 a kid for a Raspberry Pi. I mean, state school budgets for computing are so tight that actually a classroom, £1,000 for a classroom just for Raspberry Pis, never mind the cables, is not on their agenda. So I'm just wondering, 100 quid, I mean, there's private schools maybe, and special needs schools maybe, because they've got bigger budgets, but I think you go to your average state school and given what I get, I'm sure all the people in the business here are getting schools coming to them saying, can you sponsor our Raspberry Pis?
Yeah, I think this is the guideline from the Raspberry Pi Foundation, that if we can get a decent development platform for hardware for Raspberry Pi, including Raspberry Pi below £100, that this is something that will be appealing to schools.
What about the case for the Pi? Because once you use the side cable coming out of it, you can't use, well, certainly can't use the RS case, and that's where the sensitive electronics are, where you do not want people dropping solder and other things. So have you thought about that? Because I think that is important, especially in an education environment.
Well, that is a good question. Perhaps we need a case that allows this cable to come out.
I think you do. Yeah.
Yeah, that's interesting.
Yeah. Okay.
I can laser cut a case for you.
Sorry.
Two questions, one of which you covered already, which is why you worked yourself out of a market by supporting just the GPIOs rather than a USB bridge. And the second one is, what kind of plug-unplug cycles do you rate your module connectors at, and the IDC connector and the push buttons and stuff? Because they're going to take quite a beating, right?
Yeah, I guess this is something that can last for a good couple of years in the education environment with constant plugging in and plugging out. And I would have to have a look what are the specifications for these connectors, but these standard gold-plated connectors can go 100,000 cycles, which is quite a lot.
Because obviously, that was the big problem with the production, the initial production ramp on the Raspberry Pi, was finding connectors that met the spec. So they had lots of trouble with it.
Good point, yeah.
I'm slightly unclear about the domain. Is this the insertion to the mechatronics project, or is it design your own module to plug in it project, as it were?
Yeah, the intention is that, so it really addresses two groups of students. So the part of students that want to, that intend to write software to actually make some things happening in the real external world. This the students would get ready-made modules that they can buy. And the others who want to actually build their own modules, they have an opportunity to plug in whatever they build. And they can either build it by hand on the prototyping boards, or they can design it in software like Design-Spark PCB, or in fact any other software, and plug it into the Pi node.
So, I understand the first market, that's sort of like build your own robot, as it were. And the second market, I mean, given you've got digital I/O and analog I/O already, what other modules are they going to build?
What are modules they're going to build?
So I'm okay, given this,
Anything that is connecting to a communication bus, so any chips that are going on I2C or SPI can be put on these modules.
shall I just try and work out what you know, given what it does already, what else would you want it to do?
Well, if you look at the Arduino shield list, there's more than 250 expansion boards for the Arduino, which already provides digital I/O, analog, etc. So people will find applications for it.
Okay, guys, I think this is kind of now a pub conversation. And it has to be, because we're well overdue for getting out. So please, will you all help to clear up all the, stack all the chairs and generally tidy up and get out of here ASAP. After which we will go to the best pub in London.